All right, we're going to look at another example of taxes, but here we're not just going to draw it out graphically. We're actually going to use numbers to identify the different areas within this graph. So we're given a demand equation. P is equal to 100 minus Q. So I can graph that out. Here's my downward sloping demand equation. My y-intercept is 100. It has a slope of -1, so that's going to take me down to 100. So there's Q and P. My supply equation is P is equal to 10 plus Q. So that's going to start the y-intercept at 10 and have a slope of 1. Same slope as the demand curve. Okay, now I can identify the competitive market price and quantity by setting those equal to each other. If I set them equal, so to find this Q star, I have 100 minus Q is equal to 10 plus Q. I get 90 by bringing the 10 to that side, add Q to that side. It's 2Q, Q star is 45. So in a competitive market, the optimal quantity is 45. To find the price, I just take that 45 and I plug it into either the demand or the supply. I'll get the exact same answer. So put it into the supply, 10 plus 45 is 55. Put in the demand, 100 minus 45 is 55. So the optimal price is 55. That's a competitive market. Now what we notice is there's a tax on consumers. And it's a $10 per item. So if we're going to tax the consumer, that's going to shift the demand curve down, and it will shift it down by the size of the tax. So this downward shift is that the tax is 10. And so what this does is with the tax, the new demand equation is P is equal to 100 minus Q. So that's our original demand equation, minus 10. So it's going to equal P is equal to 90 minus Q. And so if we think we're here at 100, if we subtract 10, that now is our new y-intercept, which is exactly what we showed here. It has a slope of -1, so it'll take us to 90. Right? So that's how we graph out the tax. Right? Is we just take the demand equation and subtract, because we're shifting it down, the size of the tax, which is $10 per item. Now we identify this point right here, where the new demand equation is equal to the original supply equation. And then I draw this line here. The reason we draw this graphically is it's really going to help us solve it out algebraically. Okay, so this Q with the tax is where our new demand equation, the red line, is equal to original supply equation. Okay, so to show that, so this point here, we'll draw this out here, is our original supply, 10 plus Q, is equal to, because that's where they intersect, 90 minus Q. And now I can solve for Q. So I bring this Q to that side, so I'll get 2Q is equal to, subtract 10 over from that side, 80. So Q with the tax is 40, which is going to have to be lower than 45. So here we showed that the new quantity is 40. Now the question you want to ask is, well, I just put that into supply and demand, but it's important to know which one you're putting it into. So we're going to put that into the original supply equation to get the price of the seller, and we'll then plug that also into the original demand equation to get price of the buyer. Okay, so original supply equation is 10 plus Q. So to find the price of the seller, it's equal to 10 plus Q tau, or Q the tax, which is equal to 10 plus 40. So the price that the seller receives, the price goes down, and that's 50. Now to find the price of the buyer, I can note that it's going to be 50 plus the size of the tax, which is 10. So it should be 60. But I can also show that by putting the price to the buyer is equal to 100 minus the quantity from the tax, which is 40. So it's 100 minus 40, which is 60. And so we can find that two different ways. Both ways will get you the exact same answer. So now we found the quantity with a tax, which is 40. We put that into the original supply equation, get the price for the supplier receives is 50, but the price that the consumer pays is 60, and that difference in price is the size of the tax. Well, now I can identify the different areas that we've talked about. Okay, so the first area to note is our consumer surplus, which is this area right here. Okay, and this is consumer surplus. So how do you find the area of consumer surplus? Well, it's using the area of a triangle. So consumer surplus is equal to the area of the triangle, which is 1/2 base times the height. So it's 1/2 times the base, which is the quantity of the taxes, 40, times the height, which is 100 minus 60. This distance here, which is also 40. So consumer surplus is 1/2 40 times 40, which is equal to, I'm just going to get my calculator out, I probably should be able to do this. 40 times 40 divided by 2 is 800. That's our consumer surplus. Our producer surplus is this triangle here. So to calculate producer surplus, so we'll do it over here, is equal to 1/2 the base, which is this distance here again, which is the 40, the QT, times 50 minus 10, which is also 40. And so it comes out to the same answer, which is 800. So consumer surplus is 800, producer surplus is 800. Now let's find the tax revenue. The tax revenue is the number of units sold, which is QT, times the size of the tax. So that's not total revenue, but tax revenue. So we'll make it a little tau. All right. And that tax revenue is equal to, it's a rectangle, so it's just base times height, 40 times the size of the tax, which is 10. So tax revenue is 400. And lastly now, to find deadweight loss, is going to be 1/2 base. The base is this distance here, so it's 45 minus 40 times the height, which is 10. So it's 1/2 5 times 10, or 25. And now if I add all those up, if I add 800 plus 400 plus 25 plus 800, I should get the same answer that I got for the total surplus from the original competitive market.